Okay, now we'll see measurement of inertia. How do we exactly measure the inertia? So measurement of inertia. So what is measurement of inertia? So mass is the measurement of inertia. Heavier the object is, difficult to move the object or difficult to stop the object. Both the things, whether to move or stop or change the direction. So if you have a truck and if you have a bike, if you compare these two, if they both are at rest, if you want to start a bike, you need to apply some force, and for truck, if you want to start, you need to apply some larger force. So truck is having more inertia. So why it is having more inertia? Because its mass is more. So mass is the measurement of inertia. Similarly, if a truck is moving and a bike is moving, if you want to stop the bike, you can stop it by applying some force. But if you want to stop a truck, you need to apply a very large force, because truck is having very large inertia, and that inertia is due to its mass. So the inertia is measured by the mass of an object. So mass is the measurement of inertia. Mass is the measurement of inertia. Larger the mass, more the inertia. Larger the mass, more the inertia. Or you can say inertia is proportional to mass. Inertia is proportional to mass. You can say it's larger the mass, larger the inertia. We can also it can also be given by some other relation. Suppose inertia is proportional to square of mass, but that is not the case. The inertia is directly proportional to mass. So this thing we should know. Okay, now we will discuss the concept of linear momentum. So these things are related to this concept. That's why we are discussing. So what is linear momentum? So linear momentum is the product of mass into velocity. So what is this? What is the meaning of this? So consider an object. Suppose you have a tennis ball and you have a cricket ball. Both are thrown towards you. So which will damage more to you? Which will give more damage to you if you put your hand for catching these two objects? The cricket ball may damage more, may give more damage to your hand, because the cricket ball is having larger mass. So if two objects are thrown towards you, then the heavier object tends to give more damage with respect to the lighter object. So this tendency to give to apply the force or to give a damage is called the momentum. I am explaining it again. Suppose you have an object. If that object is moving, and if you try to stop that object, then you need to apply some force to stop that object, and you will be, and correspondingly you will also have the force applied by that object on you. So that force, whatever force that object applies on you, or whatever force that gives some damage to your hand, or by whatever means you are going to stop, so whatever effect that is going to give, that depends on the mass of the object. Heavier the object, the more force you will experience. So to stop the cricket ball, you have to apply more force. Similarly, if you have, suppose, two cricket balls, one ball is moving at a speed 2 meters per second and second ball is moving at a speed 10 meters per second. So 10 meters per second is higher speed and 2 meters per second is smaller speed. So if you want to catch these two balls, the 10 meters per second ball is going to give more damage to your hands when you stop this ball, because the velocity is more. So what are the things which are coming in this picture is, one is mass and second is velocity. If you take the product of these two, if you take product of mass and velocity, you are going to get a quantity called linear momentum. And this is the thing which you are experiencing actually. When you try to stop the ball, you are experiencing the force corresponding to this quantity P. This is called linear momentum, and this is equal to product of mass and velocity. So how do we define linear momentum? It is product of mass and velocity. It is product of mass and velocity. And what is its physical significance? Its physical significance is when you trying to stop that object, then how much force that object can apply on you, how much force that object can apply on you. So that is related to this thing, linear momentum. Okay, so what is linear momentum, what kind of quantity is this, we will discuss in a little more detail. So first we will see its unit of linear momentum. Since we have mass, that is kg, and velocity is meter per second, so its unit will be kg meter per second. Then it is a scalar quantity, sorry, it is vector quantity. Vector quantity. Why vector quantity? Because mass is scalar and v is vector. So the direction of momentum is in the direction of velocity. The direction of momentum is in the direction of velocity. So we can write like this. And if you see momentum, how it is related, how the momentum is related with respect to different frames. If you see momentum from different frames, will its value will remain constant or different? So if observed from different frames, if observed from different frames, the value of momentum is value of momentum will be different. Why different? Because velocity is different from different frames. Different frames means what? Means suppose you are moving in car, you are moving in train, or you are observing from ground. From three different places, if you are observing the momentum of an object, so you will see the different velocities from the three places. We have discussed already the relative velocity concept. So the velocity of an object is different from different frames. So if velocity is different, the momentum will also be different. If observed from different frames, the value of momentum is different. So it is frame dependent quantity. It is a frame dependent. Okay, so this is the linear momentum. Okay, now we will discuss Newton's law of motion, the three Newton's laws. So those laws we are going to discuss. So what are the three laws? So first we will discuss first law. First law of motion. So there are three laws of motion, and you would have studied in the lower classes also, so you must be knowing. So what is first law of motion? If an object is having no external force acting on it, or the net force is balanced, or the net force is zero, then the object keeps on moving in the straight line with constant velocity. So we will write like this: an object keeps on moving with constant velocity in a straight line, with constant velocity in a straight line if net force on it is zero. So net force on the object is zero, or net external force we can say, or net force on the object is zero. So internal forces are always balanced, so no need to write external, internal. We can write directly, if net force on an object is zero, then object keeps on moving in the same direction. So this is nothing but the law of inertia. So this is the law of inertia which Galileo gave. So the Newton framed the same thing in by saying it a first law of motion. Similarly, we have second law of motion. So what is second law of motion? So if we say the first law we can say in mathematical form, if F equal to 0, then A equal to 0. This is the first law. If F equal to 0, the force is 0, then acceleration is 0. Acceleration is 0 means what? The velocity is constant. The object keeps on moving in constant, with constant velocity in a straight line. Okay, second we will see. Second law. An object if applied a force F, if applied a force F, then and having force F and having mass m, then acceleration of object of object is given by F by m, means the acceleration is proportional to force and inversely proportional to mass. Acceleration is proportional to force and inversely proportional to mass. In other words, we can say F equal to ma. Okay, similarly we write the third law. So what is third law? Third law is for every action there is an equal and opposite reaction. For every action there is an equal and opposite reaction. Okay, so we will discuss all these things. So what is action reaction? Here in third law, the action and reaction are actually the forces. Action is one force and reaction is just opposite force of that.